And now, without further delay, I'd like to turn the presentation over to your speaker, Michael Wang, Lead Program Manager. Michael, you have the floor.
Okay, thanks. Hi, good morning, everybody. This is Michael Wang. I'm the Lead Program Manager of the SQL Server Relational Engine, and our team is majorly responsible for the T-SQL feature improvements in terms of programmability and developer productivity. So I gave a talk last week, basically for the new date and time types we introduced in the new release of Microsoft SQL Server 2008. And today I'm going to give you a presentation about another new system type we created. It's called HieracrhyID. Basically, this type is specifically for dealing with hierarchical data. As you guys know, hierarchical data is not relational. However, it has been the hierarchical data is used very common in the relational database. So for people when you have Fortune and mailing lists, for business organization charts, for product catalog, for file folders management, and for content management categories, all those scenarios require the certain semantic and programming model operate and query hierarchical data in the relational database. So traditionally, as you guys know, some people, they do use the self-join semantic by create a child ID, create a parent ID, by using the existing SQL Server feature called common table expression by doing recursive queries and query hierarchical data. Or on the other hand, some people, they can use XML by really store all the hierarchical data in XML as a whole documentation and put the tree in the database and use the XML semantics to really manage and query and operate on hierarchical data. So by having said that, the new HieracrhyID we introduced, we target to provide customers a new programming model and a new semantics by take advantage of this native type and associate methodology we created for this type for you guys to really operate and query the hierarchical data in the relational database world. During my talk, so you guys can feel free to give any questions, and I will try my best to answer your questions based on the time. If the time is not allowed, you can always feel free to send me any emails after the talk, so I can get back to you after that. So right now I'm on slide 4. This slide, I'm trying to give you a general idea about what this new type is about and what's the domain knowledge of this new HieracrhyID type and what's the properties. So basically, this type is a system type. It's a system date type with variable length. It's a CLRUDT type. However, it's a system building type. It's a little bit different from other native date types. For example, like new data and time types we introduced. They are like native building type, but this is a CLRUDT type. However, we're building in the system. So it's different from regular user-defined type. It's a system type. Because it's a CLRUDT type, then there's we also have the namespace for that type. It's called Microsoft.SQLServer.type. It's basically this type is located in that namespace. Also, we do have assembler DLL, which is associated with this type. It's called Microsoft.SQLServer.types.dll. This DLL will be shipped also across the client side. So for people developing a client application want to take advantage of this new type or this new hierarchical information we created, you can take advantage of your using this assembler for your client-side application. Internally, this type is basically the internal type is a var binary type, and we store the value of the hierarchical node information into this var binary. So in general, this hierarchical ID type is just used to represent each node in the tree. As you can see from the right side, the hierarchical tree is the most common form for storing and operate hierarchical data. So basically, it's a tree hierarchy, and the hierarchical ID, the value of the hierarchical ID is basically used to store the hierarchical path information of each node in the tree. So you can consider each node in the hierarchical tree as basically a row in the relational database table. So each value, as I said, each value of hierarchical ID data type is stored the path information of each node in the tree. So for example, if you look at on the third level, the fourth node, /1/1, it's basically, that's exactly the hierarchical path information start from the root node until this node. So this is by logically, that's what we store in this hierarchical ID value. So in order for you to really tracking your hierarchy path information of each row in the hierarchical tree. In addition, because it's a building CLRUDT type, we also create a rich building methods and all the functionalities for people easy to manipulating, operating, and to query, to insert, update the hierarchical information associated with hierarchical trees. And the way of doing this, one of the advantage of creating this hierarchical ID type is we really provide easy to use and simplified query programming model for people to operate and query on hierarchical data. In terms of comparison, the hierarchical value stored in the hierarchical ID column is basically byte order. So as you can see from the right side of hierarchical tree, so /1/2 is basically has a bigger value than /1/1. Why? Because we don't do anything fancy. We just store the value by byte order based on the depth, based on the level of each node in the tree. So we use that as the correlation to do the comparison. So basically, the comparison is in depth first order. So A smaller than B basically means, well, B has either has a bigger level than A, or B basically on the right side of node A. We also, as I said earlier, instead of only query hierarchical data, we also provide a very efficient and very performed insert and update and delete operations through those methods for this hierarchical ID type. So let's go back to, let's see if there's any questions pop up. I do see some questions pop up here. So yeah, there's three questions. First question: are the past presentation available online? I couldn't find last week. I guess what you talk about is whatever talk we gave last week. So yeah, so my understanding is they will be online. So if you still cannot find them, send me email, send Provina email. We will get back to you. So cannot see the slides. I think Fred said cannot see the slides. So I hope you can see that right now. If you still don't, send me another question. So this is a technical question. It's sibling order maintained or guaranteed? Actually, that's a very good question. I'm going to have another slide to talk about that. So in general, we don't. The hierarchical ID support we provide, we don't provide the semantics for you to maintain the order. So it's really, for example, if you delete a parent of a child, so we append to the application to really have their own semantics to make sure when they delete a parent node, so they can make sure, okay, there's a child node underneath that, so they can really to make sure the order is not screwed up. So internally, the hierarchical ID type for this release, we don't provide that dynamic semantics of maintaining and guaranteed ordering. However, if you follow the guideline and the methodology we provide for you to insert, update, the hierarchical ID nodes. The order and the order information should be okay, should be guaranteed. So you don't have to worry about, because you use those methods to generate hierarchical ID. As long as you follow that, you should be fine. But if you do any, like delete, update operation by your own, you have to create your application's own semantic of dealing with that. So let's go one more question. Yeah, so that one I'm going to skip. So yeah, this question is, what's the max number of siblings on any of given level? So I guess this question is like, what's the maximum number of nodes you can create at any level? So so the answer will be, well, actually there's no limitation. So basically, as I said, we use a 900 bytes var binary to store the hierarchical ID value, and we have our own internal encoding semantics by providing, based on the logic hierarchical path information, we store that. So based on our calculation, you can consider you can store unlimited number of nodes in the level, even in the tree. So it's going to be okay. So you don't have any limitations. Okay, I will go back to the slide. So I'm on slide number 5. In addition to provide a better programming model for dealing with hierarchical data, the performance is also another very important perspective. Also, people really care more about. And so we basically, in order to make sure the performance either has a better way to perform than the existing self-drawing parent ID, child ID idea, as well as XML semantics, we basically did something specifically in terms of to provide some special index semantics for support this hierarchical ID type. So there are two basic index semantics I want to specifically mention here. The first one, we call that depth first indexes. So what that means is basically when you create a column of hierarchical ID in your table, you create a unique index or primary index on that hierarchical ID column. By default, we will use this depth first index semantics. What that means is like, so for all the rows in a subtree, we basically consider them on the same group. So we store them very closely near each other. So for example, when you try to search all the direct and non-direct reports to a manager, basically using the depth first index will be the fast way to get you the results, because we basically, as I said, we store all the subtrees, all the nodes under the subtree near each other. Another index semantics we also provide is called breadth first index. So what that means is basically we store the rows on each level, basically directly reported to the child, to the parent. All the direct childs will be stored near each other. So in order to create this index, it needs to be a component index. Basically, you have both the hierarchical ID and the level information there in order for you to create such breadth first index. So as an example, if you want to search all the direct reports to a manager, by having this breadth first index, definitely going to will give you the quickest way to get your results. Later on, I'm going to have some case study and going to have some examples, code examples, to show you how you create those index and basically how you take advantage of that for different scenarios. Let's go back to the question and see if any more. Okay, there's one more here. The question is, what is the best upgrade from 2000 to 2005, then to 2008, or go directly from 2000 to 2008? Well, this is seems like a question not specifically related to this talk. So, by my understanding, well, I'm not a good people to answer this, but I think the best Yeah, so we can talk about this offline, or you can either drop me an email so we can get back to you for this kind of questions. Thanks. I'm going to continue. Right now I'm on slide number 6. As I said, currently there are two major approaches when people in the database world, they really query and manage and operate on hierarchical data in the database. So the first one is basically you use the parent and child ID approach by doing self-drawing or using the common table expression recursive query to achieve your goals of operating and querying hierarchical data. So by comparing the new hierarchical ID support, we just, as I mentioned, for the new release, if you do a subtree queries using the hierarchical ID, the new hierarchical ID semantics will be much faster. And if you do a direct descendant queries, for example, if you want to query all the direct report to this manager, and or if you do a insert updating nodes operations on the tree, so basically they have hierarchical ID is slightly better, but in general they have most likely they have the equivalent performance results. And as I said, if you do a direct descendant queries, if you use that brute force index, that will speed up your performance. So in general, hierarchical ID, particularly when you do subtree queries and all the popular query operations, hierarchical ID not only give you a better programming model and for you easy to use, easy to develop, and also give you a better than the average performance, as you can see from the parent-child self-drawing semantics. So as I said, another common semantic is you're using the XML data type. So that will be, you're using XML is basically supposed to be the best way to deal with hierarchical data. Why? Because XML document by definition is a hierarchical tree format. So that's really all the XML functionality, all the XML operation semantics is built around the hierarchical tree. So using XML, if you have hierarchical data, you want to store in XML documentation and really play and query with that, of course, that's considered, a super idea compared with any other approaches. However, you also have to realize when you use XML approach, you have to have the complete hierarchical information stored and retrieved in the database, which means you cannot do that partially. So if you only do partial XML, it's not going to help. Also, on the application side, your programming model has to be XML-based. You cannot only say, I'm only do partial XML, but then using the T-SQL to do another part. Well, that won't give you any advantage of using XML to deal with hierarchical data. And also, XML in general is not very good in terms of predicate search, in terms of conditional searches, because they don't have the equivalent technology as what SQL does in terms of predicate queries. So by having said that, so if you cannot satisfy most of the conditions by using XML, well, I would recommend hierarchical ID is another good approach for you to do in the T-SQL world by using the SQL language and to really program in against the hierarchical data. Let's go back to the question, see if there's any more there. Okay, so far there's one more. So the question is, would SQL Server team recommend using hierarchical ID for modeling DAGs, direct assist graph? So as I said earlier, the type hierarchical ID type is specifically introduced for dealing with hierarchical data for people to store and operate and query and manipulate hierarchical data in the relational database. So for any data which you really fall into this hierarchical data category, I assume this DAG is basically is definitely in this category. So hierarchical ID is definitely a new solution for us to recommend, to use when you deal with hierarchical data. But as I said, I mean, just in the last slides I talked about, hierarchical ID is not the only solution currently in the database world to deal with hierarchical data. So there have the hierarchical ID information has pros and cons compared with others. So depend on your situation, right? Depend on if you have more query operations or you have more update, delete information, or you really you care about the performance, or do you care about the programming model, or you care about the application porting semantics. So based on different needs, right? So hierarchical ID definitely has its benefits, but however, it's not the only best solution in the world, depending on your scenario. So in general, I mean, this is a good type, and this is a good semantic, we believe, for people to deal with hierarchical data, and we really, make sure we have a rich programming model for SQL Server when you have hierarchical data stored in the database. Okay, so I will keep going to the next slide. So right now I'm on slide number 7. As I mentioned earlier, in addition to the hierarchical ID type and all its semantics, we also create all the necessary and important building methods for helping to manipulating and query and operating on hierarchical data. So as you can see, there's a list of methods here. So like the get root, you basically help it's get root and get label, they both static methods, and for you to really get the hierarchical tree rows and also get the label information of each row, of each node in the tree. The reparent, the third one is called reparent. Basically, that's used for when you want to move the node information and enter a subtree to another new subtree. For example, there's a reorganization. All the people report to one manager and going to report to the new manager. So you can use this reparent. This is a very common semantic, again, in the hierarchical tree scenario. So this is a very good method to really make people's lives easier in terms of programming and operation. Another one is a Boolean method. It's called its descendant. Basically, it helps you, to determine where the node, to determine the parent and the child information of a given node. And the toString method is also a very interesting one. Basically, we provide this method for serialization to string format and give you the logic conceptual model of what a hierarchical path stored in the node looks like. So you will use the slash as the separator. As you can see, the example I gave, it's basically definitely give you a direct conceptual model of each value stored in the hierarchical ID column. And the last three methods, parse, read, and write, basically we provided some conversion semantics for you to really convert between binary and string values with the hierarchical ID information, because internally the hierarchical ID is stored as var binary. As I mentioned, we have a special storage semantic of stored value. So by using this three methods, you can back and forth do the conversion among each type with the internal values. So the next slide, also I'm still on the slide number 8. I'm still on the building methods session, and there are two also important methods. The first one is called get descendant. The major use of this get descendant method is for insert and update use. Basically, this will automatically generate a hierarchical ID value when you want to create a new node and put into the tree. And there are two parameters, basically. The reason we have two parameters is because we want to make sure we can provide you position-based insert semantics. So you can basically, based on, if you can say, I want to the node I want to insert is going to be on the right mode. So you can specify the child 2 as by giving a null. So we know, okay, you want to have the rightmost position in the same level and put that new node there. So basically, if you want to say, okay, I want to really put this node between child 1 and child 2, you can also do that. As you can see from the example here, basically I'm trying to insert a new row, a new node into this tree, and on the last position in the same level. So that will get you to do it. So you don't have to worry about how this hierarchical ID value has been generated. We generate that for you, and as long as you follow this by calling this method, you'll be fine. So your order of in the hierarchical tree will be correct. Another interesting method is called getAncestor. It's basically to try to give you the parent information based on the level you mentioned. If you specify level 1, it will give you the direct parents. If you specify the level parameter as 2, you will get the grandparents information. So this is another method for you to really deal with child-parent relationship when you're programming against the hierarchical data. As you can see, the example I gave here is basically if you want to select all the nodes report to this manager, so you can find all the nodes, their parent, the direct parent is this current employee. So that will give you all the direct report to this parent. So let's go back. I'm on slide 9, but before I keep continuing, let me go back to the question. There's another one. Okay. So the question is, are these .NET functions or T-SQL extensions? So the question is, are those measured .NET functions or T-SQL extensions? Basically, because as I mentioned earlier, the hierarchical ID type is a system type, but it's a system built-in CLR UDT type. So because it's a CLR UDT type, so all the method is a CLR method. So to answer the question, yes, they are .NET functions, and by using the CLR programming code to really generate those new methods. However, as you can see in my example, you can just call them by treating them as a regular T-SQL user-defined function, which is as a measure of her hierarchical ID type. So I'm on slide 9. Let's keep continuing. So because this is a CLR UDT type, so people might wondering, well, can I do all the DDL operations against regular user-defined type? Well, because this is even though this is CLR UDT type, but it's a system building type, so there's no difference from any system native type we provide in the SQL Server space. So because of that, there will be DDL restrictions. So for example, you cannot auto the assembler, you cannot drop in the type, you cannot change the assembler, you cannot change any user reference, you cannot create a Alice type that Alice a system CLR type. So those abilities you can do for regular CLR UDT type in terms of DDL operations. Is limited because they're system building types, so we cannot really modify and drop them. However, for us, because it's a UDT type, so we can always, based on your feedback, we can always try to enhance the type. For example, we can add more methods if we need to, if we have to, or probably we can also update some of the semantics for the new method we created for this type. And that depends on the customer's feedback and how you guys feel about it. Okay, so right now I'm on slide 10. I think in the next several slides, I'm going to go on a case study by really modeling organization chart and to go through to give you some ideas in terms of how you operate hierarchical data which representing organization management information, and how you create the roles, how you create the index, how you query, how you do the updates. So I'm going to do this case by case and by using some code examples, so you can have some good understanding about how really you can use this new feature in SQL Server 2008, and what's the best practice you can get when you have any requirement on deal with hierarchical data, and what's the issues you might be able to find and let us know. So I'm going to start from slide 10. So as you can see, basically it's very simple. So you can create a table instead of all the way you have to create a parent ID and a child ID, 2 columns, and create also a component index on those 2 columns. You can just, in the old self-drawing way, by using the new hierarchical ID support, you can just create a single column by using the hierarchical ID type, as I showed you guys in the example. Then also you can have another column called level by using the static get level method. The reason you have a level column here because, as I mentioned earlier about the index semantics, so you can use that level and hierarchical ID column to create a component index if you want to create the brief first index and using the brief first index semantics. By default, if you can also create a column on the hierarchical ID column that will give you the depth first index semantics, and you can make sure, if you really care about the uniqueness of the index, make sure you create a unique index on that. So, and we'll take care of that, the uniqueness, when you for creating those index keys. So when you're adding the fourth node in the hierarchical tree, or the fourth row of your table, so you can use the get row method that will give you the fourth row of the whole table, and from the tree perspective, that will be the rows node. So next, of course, now when you have the table created, when you have the tree set up, then you want to adding the sub nodes, which either report to a manager or basically all the child to the parent to the node, right? So from the example, as you can see, as I mentioned earlier, the get descendant method is really the major method that you want to use when you do insert, because that will give you automatically generate the hierarchical ID, the new hierarchical ID you're going to insert, as long as you specify the position of it. The example I gave is basically you find the maximum node, the rightmost node from this row, and you basically put the new node after that. So that will be the new employee you added into this table and report to this manager. So this is a very, as you can see from the programming model perspective, it's very easy to program, and it's give you a direct conceptual model in terms of tree operations on the relational database world. So next is it's also a very common operation in hierarchical data when you're dealing with hierarchical data. It's most likely, as I said, when you want to moving an employee to report to another manager, for example, this employee switch groups, and how you deal with that. So as I mentioned earlier, there's a very important method called the reparent. You basically that will help you to switch between parents for any given node. So as you can see, you basically use this reparent as long as you specify the old parent and the new parent based on the employee, the manage ID, and then you use the reparent method. That will give you to make sure the existing node has been switched to a new manager, and to the hierarchical path information will be changed, and then your role will be basically have the different parent-child ID child relationship between this update child node and the new parent and the old parent node. Let's go back to see if there's any more questions on this. So the question is, what would happen if two concurrent sessions try to do manager that get descendant? Will they get the same hierarchical ID for the new child? Actually, that's a very good question, and I'm going to mention this as one of the limitations. So currently, the new hierarchical ID semantics, we don't deal with any concurrency information when you basically when there's two sessions try to do the same operations. So we rely on the application to build your own semantics. So for example, you can create your own logging semantics and or by using mutex semantics to really make sure the concurrence has been paid attention. So the issue like that won't happen. Internally, the get descendant method or the hierarchical ID type, we don't provide any automatically methodology or semantics to deal with concurrency problems. So at least not in the release. In the future, probably we will consider that. One more question here. What if I switch off the CLR at database level but want to use the hierarchical ID? Very, very good question. As you know, the switch for using SQL CLR is basically specifically for user-defined CLR so procedure or CLR user-defined type or CLR user-defined functions. However, because I said this is a system building type, so internally we just the CLR is hosting it internally already. So using of the hierarchical ID type won't be affected by the switch for user perspective when you really switch on and off for CLR users. So either way, whether you set the knob for CLR use on or off, this type is always take effect because it's a system building type. So in other words, it's not dependent on the knob for CLR enabled control. One more question. Can I use the hierarchical ID to define a hierarchy in an OLAP dimension instead of using the parent-child ID type? Very good question again. So the answer is, of course, you can use hierarchical ID to define a hierarchy for your OLAP dimensions instead of the parent-child ID. And we do provide a white paper and the tutorials for you in the book online, and for you to really make sure when you want to migrate from your existing parent-child ID semantics or solutions to the hierarchical ID support. So you can basically follow that by really migrate your current solutions from parent-child ID approach to this hierarchical ID feature. So let's go back to the slide. Right now I'm on slide 13. Again, this is also about the use of reparent method together with the is descendant and get descendant and get entrance. So basically, when you want to move a subtree to a different parent, basically, in the real world, there's a reorg happens, so all the people reported to one manager has been reported to a new manager. So this is, again, a very typical hierarchical data operations for you to move the whole tree. And, compare with, so let's go back to slide 12. This is only basically report for you to only remove one node instead of the whole tree. But you also use reparent. Again, if you want to you want to shift the whole subtree to a different location, reparent is also definitely give you a big advantage of doing that. The example I have here is basically, first of all, you identify the old parent and the new parent, and then you basically use the update statement, and then you use the east descendant to really travel the tree and to make sure all the child of the old parent has been taken care of and moved to the new parent. Again, the hierarchy information of each old child node has been updated to reflect the new hierarchical path under the new parent node. So slide 14 is basically it's also a very common query operation. Is if you want to find all the employees report to a manager, whether it's direct report or indirect report. So basically, you can use this, as I mentioned earlier, using this east descendant method will basically travel the subtree and find all the information and return that to you. Again, because we create a depth first index on the hierarchical ID column, so this one will give you very fast performance by using that index for you to find all the direct and non-direct reports. Basically, as you can see, it's a recursive tree search operation on this subtree. So another one is, what about I want to find all the employees reporting directly to a manager? So this is about direct report search. And again, as you can see, each descendant template is going to be the one you're using. On the other hand, you use the get level to make sure all the nodes on the same level has been returned, right? So because that's really if you don't give a parameter on the get level is basically, well, that's going to be the immediate level after the parent. So it's all the direct reports by using this query will be returned. Also, this query will take advantage of the breadth first index we created by using the level and the hierarchical ID column, create that component index, if you remember, when we create the table. So this one definitely going to take advantage of that index and give you the quickest result as you can find. Yeah, slide 16, again, I think I showed this earlier, but I just want to make sure I give you this one more time. It's basically tell you how you display that, if you for display purpose, or you want to get a direct, user-friendly representation for the hierarchical ID information you saw in the database, and to display that in the report or for whatever purpose, you can use this toString. Will give you a string format of the hierarchical path, what that looks like. We use the slash as a separator, so as you can see, you can just use the toString. It will get back to you, the readable string format information, and you'll have really a good idea in terms of what the tree looks like, what each node looks like, in the hierarchical tree. So, yeah. So let's go back to the question before I go to the limitation slides. So the question is, if you feel about concurrency, if the concurrency control is responsibility of the application, would SQL Server 2008 provide explicit row-level locking similar to what Oracle allows, like start from table where ID equal to value for update? This is a very good question. Again, row-level locking is something we're considering, and not only for this hierarchical ID type itself. It's in general. I think I agree with you. I think providing a row-level locking definitely will help. To solve the concurrency issues as you mentioned. I agree. So this is a very good question. and we are also definitely considering of doing this in the new release. So in terms of limitations, so the first one I want to specifically emphasize is this hierarchical ID column is not defined to automatically represent the tree. So the hierarchical ID value stored in each row is not represent the tree, but represent the node in the tree. So it's basically represent the hierarchy path of each node in the tree rather than the tree itself. However, by following the semantic and the methodology we provide, you definitely could take advantage of this hierarchical ID feature to optimize the hierarchical tree for your hierarchical data in the relational database. So if you really want to make sure you have a tree management application, so you can definitely taking the advantage of the hierarchical ID feature and all the methodologies we provide, and make sure the tree information has to be is being maintained completely against your purpose. The second one is basically I already mentioned the questions people bring up in terms of concurrency and also the uniqueness of the hierarchical values. So currently we don't provide internal semantics or automatically methodology or mechanism to really help you to control the concurrency instead of any existing locking semantics we provide for general table and row level locking. However, for example, on the other hand, we also don't guarantee the uniqueness. So you need to either create a unique constraint, or if you create a index, okay, that's it, you create a unique index, and make sure you create a unique constraint if you really want to make sure the value of hierarchical ID being unique. Because we don't currently, when we generate a new hierarchical ID, we don't track the history information we have generated for hierarchical ID information. So we don't guarantee the uniqueness. The last one is the relationship between the parent and child relationship. The hierarchical ID feature we provide, we don't give any restrictions between parent and child relationship like what we did for foreign key relationship. So having said that, I give you an example. If you want to somehow you delete a parent of a stable child, so it's really the application's duty to make sure when you have that such operations, you want to make sure you're taking care of all the child before you delete a child. And we don't really internally, we don't guarantee we will make sure the child parent relationship has been either established or fixed or repaired to in a reasonable way. So it's really the application's choice for you to maintain that relationship when you do such operations. Again, this is something we will consider probably in the future release, but definitely those limitations it will exist in this current release when we get this new hierarchical ID type out of the door. With the CTP4, the SQL Server 2008, the bit you get, you will got, if you go to Book Online, we have all the new topics and including tutorial about how you use the hierarchical ID type and all the guidelines, all the information is on Book Online. So you please feel free to just go out there to find all the information you need. And if you find any issues or questions, just feel free to either send us an email or you can go to the connection site and open a request. So we definitely going to look at that deeply and to make sure your requirements and your feedback has been taken care of. Again, this is my email. So if you have any question regarding my talk or have any confusions for this new hierarchical ID type and the way we provide, just feel free to send me an email, and I will make sure it has been followed. So right now we have about 5-6 minutes. I will go to the questions, see if there's any more questions. Okay, there's 2 more questions here. So the question is, why wasn't a uniqueness check performed when generate a hierarchy ID? Will this in a simple check have implemented? A very good question. The only concern we have is not about implementation. It's basically about performance. Because in order for us to basically have a uniqueness check, we have to keep the history of all the hierarchical ID we created before, and we have to really travel them whenever you create a new hierarchical ID. So performance-wise, we feel this is a little bit trade-off. So that's really one of the reasons. On the other hand, we also feel, well, we probably we can create a method, a building method for this hierarchical ID type, for example, called validation. So for you guys to call before you generate a new hierarchical ID. So as I said, right now this is a new feature. This is the first release for this new feature. So we definitely have we open our mind to and welcome any kind of feedback. This is a very good question, and we will take a look at that. Again, if you really care about the uniqueness, so far as I said, the workaround is create a unique constraint on top of the when you hierarchical ID column. So the next question is, if that you are enforcing a parent-child relationship, is there a easy way to detect that? So it's a very good question. I think basically, as you can see, we do provide those method in terms of parent and child relationship, like the is descendant, get register. So it gives you some functionalities for you to determine the parent and child relationship. However, as an application, you do have to build your own semantic and mechanisms by using those methods to help you to make sure you are clear on the child and parent relationship. If in terms of when you really want to enforcing the child parent relationship for any kind of operation you're going to perform. The next question is, when will the PDF print capability be enabled? Yeah, I think it's currently enabled. So this is something probably there might be a confusion there. So let us know so we see what we can do. But I think it's currently enabled on our side, as I can see. Okay, one more question. I'm a late customer to this webcast, where I can download it as a PDF. You will definitely going to get it, So I think that you can either you go to the webcast site,
or you can. I'm sorry. Or you can go to Connect later on the week. We'll have a replay of this that you can download at your own convenience.
Yeah, and also if you still have difficulties, send me an email. I will make sure that has been distributed to the correct person to help you on this. There are 2 more questions. I'm going to wrap this up. So one question is there a plan to implement methods similar to the MDS hierarchy methods? Very good question. I think people, in the analysis service, there are a bunch of rich hierarchy methods, and we are considering definitely, because even though we're not one by one aligned with those new methods, but we do considering in the next release or probably in the future to create adding more methods to this hierarchical ID type. We'll definitely consider about that. the last question is it possible to somehow end up with HieracrYIDs as a result of a failed move reparent operation? So if I understand it correctly, I think if you're really doing the move and the reparent by following the guideline and the semantic we provided, by following the programming model as the example I was giving, you should be fine. Because unless we have a problem on our side, which I don't believe so. So your parent and child relationship, your hierarchy path information will be fine, will be correct. There shouldn't be any corruptions if you're really doing the move reparent operations by following our guidelines. So if you found any problem, please let me know. I'd like to hear about that, and then we definitely need to fix that. Okay. One last question. So Michael, I like the presentation. Please, can you resend the presentation? PDF is fine. Thanks. Okay, of course. I'm going to send the slides. Slides going to be public for you guys to take a look, and also it's going to be recorded. So you can also, as Pauline mentioned earlier, you can get all those information later. Okay. So I think time is up, and thanks everybody for listening. Have a good day. Thank you. Bye.
And before you all hang up, we do have another live meeting event that hasn't been published yet, but will be updated on the site. On September 5th, we'll be sitting down with Sarah Tahir and going over object dependencies. So everyone, make sure you add your schedule 11 a.m. Pacific time. So we will definitely send out an announcement to that prior to that, and we thank Michael for coming in and answering all your questions and giving us a little bit about HieracrYID.
And as one final update to everyone, at this time you can print off a copy of the slides from within the live meeting console. To do so, just go up to File in the upper left-hand corner and then select the Print to PDF option from the drop-down. And you're welcome to stay logged into the conference to print off the slides. But at this time, this does conclude today's live meeting. Thank you for joining us, and you may now all disconnect.